Welcome back. We spend quite a lot of time recording these lectures, and I hope that they're useful to you. I hope you actually watch them, and not just useful in terms of this course and passing this course, but I hope they really are helping you develop your identity and your career as a teacher, a primary school teacher, which means you are a teacher of mathematics. At the end of the last video, I talked about the Newman error analysis, which we did last week, and that was a reference to the form of assessment in a diagnostic form. I hope you've had a chance to have a look at that and try it out yourself as you've done some problems. So in this second part, the first part we looked at assessment, and the second part we're trying to look at developing mathematical thinking. Now, of course, one of the hard things about developing mathematical thinking is you can't actually tell what sort of thinking kids are doing because it happens inside their head. You can't see it. So you can only infer about what they might be thinking by what they do or what they write down or what they say. But nevertheless, helping students develop in their mathematical thinking is seen as a really important and integral part of the curriculum. When they leave and in their whole career, their life after school, a lot of the content we teach them they may or may not use. But if they can think mathematically and reason through things in mathematical ways, that'll hold them in good stead. And if you think about the events around the world, then often you'll get them reported using statistics and data and all sorts of mathematical ideas. And if you want to make sense of them, you need to have some mathematical thinking or some ways of reasoning mathematically so you can be an informed citizen and make good judgments about what you're going to do and respond in your everyday life. So the preview today, first of all, we want to look at planning and teaching and assessment related to that. I'll give you an example. And then we'll look at some things around measurement and geometry. And then there's some practical ideas. What we're trying to do in this lecture is give you lots of practical things, not that these are recipes you should follow or necessary tasks you should take and just do straight from here, but ones that will help you give an idea of how you might construct some of these things and how you might develop different ones depending on what you're teaching and who you're teaching and where you're teaching. So again, without having to repeat some of the stuff you've already done, we know that planning and assessment and teaching are mutually informing. It's not like you do all your planning, then you sit down and you teach, and then after you finish teaching, you do the assessment and that's it. You do some assessment, it'll help you know about your teaching, so then you might change their planning. So these things all inform each other. And I think sometimes we tend to think of these things as being a bit too linear. So while you're on prac and even as part of different courses, you would have been asked to plan some lessons and some units and things like that. If it had been on prac, then you might have also got to teach them, and then you could have done some assessment as well. But once you've written a plan, this is not like a piece of gold that you put in your folder and next year you just pull the same one out. When you're teaching, you'll have this plan. You won't, I think, write lesson plans once you start in your career, but you'll have an overall plan for a unit. And as you're teaching it, I would be writing notes on it and making changes, pulling activities out, making notes about different things we did, what worked, what didn't work, what we need to add in. And then when I do the assessment, it'll tell me about the teaching. And I taught this part well, but I need to do this part differently because the kids didn't get it. So they all inform each other. That's what I'm trying to say. And don't think of them as just set in concrete. The beauty now is when you're planning, you'll probably do it on some sort of shared drive with everyone else. And as you go along, they're easier to change. Now, I'm not going to read this out to you. You can see it later for yourself. But a lot of you would have heard of Bloom's taxonomies. And this is one that's become popular recently about levels of cognition in mathematics. And all it does is really show you from top to bottom how they get more advanced. So we start with just knowledge. Can you recall something? Can you tell me something? The second part is comprehension. Do you understand it? Can you explain it? The third cognitive level is application. Can you use what you've done somewhere else? The fourth thing is about analysis. Can you analyze it? Can you use it as a tool for working things out and evaluating things? The fifth one is synthesis. Can you pull different ideas together? And the last one is evaluation. Can you use it to prove or show things? Can you check things? Can you use it as an instrument to check in other areas? So sometimes people talk about cognitive verbs and things like that, and you can see I've put a few of them there around number, measurement, and spatial concepts, and that might help you as you think about students thinking and how you can encourage them to think. Unfortunately, in mathematics, we spend a lot of time at level 1. Do they know it? Can they recall it? Which is really the lowest level of cognition. And particularly nowadays when we have so much available to us and readily accessible. So people's, everyone's got a phone, even the kids at school often, maybe not in junior primary, but a lot of kids have got a phone. And Google's right there. If you need to know some facts, it's not hard to find out facts. So in mathematics, in my opinion, knowing facts and ideas is still useful because it helps you being able to relieve the cognitive load so you can solve other more complex problems. But actually just, if your maths curriculum is only about knowledge, then it's very limited. So we want to try and encourage kids to use, to be cognitively engaged at these different levels. So, here's an example. Now you notice it says planning for learning and assessment, because really we think it's important that you plan them both at the same time. And so this is a Year 5 assessment in measurement, and the topic is area. You can see thousands of these in your schools you've been at. When you've been on prac, when you start your job, there'll be a lot of them already in folders or on learning management systems in your school. And of course there's many of them online you can find. Just be careful if you download them from different countries, because sometimes it's not appropriate. Even different states of Australia can be different. But there's lots of resources there. And when you get these resources, don't just take them and say, I've got something, here it is, I'll use it. Even if you get them from Queensland, what you do is it's good to get ideas from elsewhere. You don't have to invent everything. And then look at it and say, how can I modify this for my students? How does this fit with our community? What about my teaching style? And to take it and then modify it, and then you can use your modified version because it's made to meet the needs of your students in your school. Now I'll just show you what it looks like. I'm pretty sure you can't read it, particularly if you're watching this on your phone or something. But I'll put a copy of this in the Learning at Griffith site too, so you can download it. And you can see some of the features that are in it. It's just an example of one way of planning. And for every school, there'll be different ways of doing it. And we don't give you one recipe here. There is no one way of doing it. You just need to find what works for you, what works for your school, which may prescribe how you do it, and works for your students. So it's an example. So this is trying to again promote about mathematical thinking. So one of the things we often do is just say, here's the formula for the area of a circle, memorize it, and then do these 50 to practice. And what tends to happen with that is kids don't remember it, they see it as not really that important. But if you help them to see why it works, then they're much more likely, first of all, to remember it and then be able to use it and see it of some sort of interest to them. So there's a clip there where you can see some sort of intuitive explanation, and I encourage you to have a look at it, because one of the things you will need to do when you start teaching, and you can start that right now, is actually understanding why things work. So as a teacher, if you are teaching students about the area of a circle, it's not good enough just to say, here's the formula, go ahead and do these 50 practices. You need to be able to tell them why it works. You need to understand why it works. And the beauty about that is there's lots of resources available on the web that you can find out which will help you explain why things work. So this is just one example here, and I hope you look at it and really challenge yourself in your own thinking. So what this is about is, as a teacher, Yes, you need to be able to plan. Yes, you need to have all the teaching skills. But more important than that, you as a person need to have a strong mathematical identity. You need to understand these things and be able to share it with children. Not just share your knowledge, but share your understanding and appreciation and your excitement about some of these things. Maybe that's pushing it a bit too far. But for some of you, this is a journey you need to engage with mathematics. You cannot afford to be a teacher who just thinks math's dull, colourless and boring, because that's the first thing you'll teach the kids. You would be like someone who teaches physical education, who tells the kids to live a healthy life, but you yourself smoke, drink to excess, are morbidly obese, and you don't like physical activity. That's a bit like some of us are with our mathematics class. So you can never say, I don't like maths, if you're going to be a primary school teacher. And if you do, and even if you don't say it, you can't be like that. You need to engage with it. Good part is you've got at least another year and a bit before you graduate to sort it out. All right, so here's another one. How can you work out the volume of a prison? Now again, you could just teach the kids the formula and tell them to go and practice. Probably most of them can regurgitate it if necessary, and then as soon as you've done the assessment, they'll probably forget and see it as a waste of time. So this again is another video which takes you through why it works. So again, don't mean to harp on it, but it's worth looking at it so you can understand it yourself. Now, of course, once you start your teaching career, there might always be new ideas that you think about. I know how to do this, but I don't actually understand why. It's okay, you can learn it. This is not something that is a permanent learning disability that you have. This is something that you can do. And even if you're good at maths, make sure you're just not good at it, but you also understand why things work. So you can explain it and show the kids about those things. Okay, so here we're talking about building mathematical competencies in children, and this is more than just that they can know certain things and do it. It's about some of the big ideas. And these should be throughout the curriculum, and you'll see they start early on. The big ideas are clusters of ideas and concepts that hang together. They're central and they're coherent. And what it means with our teaching is we don't just have to teach them these little separate things that stay in these isolated silos. The kids need to see that they hang together and are related. And they'll see that if you show them in your teaching. But they'll also learn that they are isolated and disconnected if you don't show them together. So for example, if students don't understand that addition and subtraction are fundamentally two sides of the same coin, if they see them as completely separate, then there's something missing in the way you've taught it to the students. But the big ideas help kids in their thinking, and they generate future learning because they get a more robust, connected learning. And some of these things we should develop right from the beginning in the early school years. So this has come out of the Association of Teachers of Mathematics, and they said there's 5 big ideas in mathematics. And they're saying they should be evident across kids learning in maths, what it means to be a mathematician, to reason and think mathematically, and to help apply things. This is what mathematical thinking is. So the first one is proportionality. Things are proportional, and this is relevant in almost every part of the curriculum. Things like proportionality you would have done in ratios and even fractions and things like that. But understanding proportionality is an important mathematical big idea, and something that you should try and build in from the beginning parts of the curriculum and right the way through. If you're not familiar with these things, have a look it up and follow it through. The second one, which you probably are more likely to have heard, is about patterns. Right, so some of you may have heard that algebra is all about patterns, and that's partly true. But the whole maths curriculum is often summed up as about patterns, and that's partially again true. It's not all true, but certainly mathematics is about identifying patterns, repeating patterns, continuing patterns and things like that. And we're not just talking about in geometry here. The heart of algebra is about finding a pattern, representing that concisely, and then being able to continue it and use it in other ways. The third one is generality, and that's about relationships. And again, one of the strengths of mathematics is it can concisely represent a lot of ideas. So an example here is if you've got a general idea, then you can apply it everywhere. You don't have to learn it in each different case. An example would be if you had a rectangle and you wanted to find the area, the first one, you'd find that you might count the space inside or something, and you'd find that it's equal to the length on one side times the breadth on the other side. Now what we've found is that every rectangle, the area is equal to that length times that breadth. So we can generalize that to say that area equals length times breadth. It's a generalization because it applies to every rectangle ever. And that's a powerful thing. So every time we get a rectangle, we don't have to sit there and work out how to find the area. We know that this generalized relationship exists and we can calculate it very quickly. And that's one of the powerful things about mathematics. The third thing about mathematics is it's representational. It's a way of abstractly representing difficult or complex problems. And it can be represented in a lot of different ways, but it's a way of pulling things together and representing them so you don't need to have the whole thing there. So, for example, if I said the number 2, that is a representation of 2 objects. And you understand that. As soon as I say 2, you know what that means. It's a representation of something that exists, 2 particular things. And often, the last one's about communication through representations. And so often the language of mathematics can be used. It can be used to communicate difficult ideas and things that can't be represented physically. So for example, a half is a mathematical concept which is powerful in communicating ideas. In the physical world, a thing of a half actually doesn't exist. If you had an orange and you cut it in exactly 2 pieces and you held them up, you don't have halves, you have 2. You have 2 objects. The half is a description to describe the fact that it was 1 and you've cut it into 2 equal pieces. So mathematics, the big idea about communicating ideas is powerful, and it's something students should be doing throughout. Now again, you can follow these things up further, but I'm just flagging them here and you know where to find them. So again, to helping students to do this, often what we do in maths is we tell them stuff. We tell them stuff and we assume they'll just remember it. But what we want students to be able to do is to think mathematically, to prove things, to try and understand things. And so to do that, often it's about asking really good questions. And these questions shouldn't be just recall questions, but they should be deep questions that encourage the students to think. So again, there's a video there, so you can have a look at that. Look at it twice if you want. But as you do that, think about how did they help the students in their mathematical thinking? How did they encourage openness and honesty, humility and wise restraint? How did the teacher show wise restraint? Because one of the things that can be frustrating you as a teacher is you see kids doing something and struggling with something, you feel sorry for them and you want to rescue them, and so you jump in and tell them the answer. And in jumping in and telling the answer, who's done the mathematical thinking? Not you, not the students, you have. So therefore you've actually robbed them of their mathematical learning. So as a teacher, you need to practice some of these sorts of things. Sometimes a little strategy, give the kids a problem, let them work on it. When they put their hand up and say, what do I do now? You might just say, keep working on it. You might use the 5 questions from the Newman error analysis. You might just need to encourage them. Or you might need to give them a probe that helps them see something differently. Or you might need to redo the task. Sorry, there's no recipe about which one of those is the right approach, because it'll depend on the student at the time with the activity you're doing in that class. One of the things in this course, we're making maths teaching more complicated and more complex. But it isn't simple. Teaching maths is not as straightforward as finding the recipe and then just rolling it out. It requires you as a teacher to be strong and engaged, mathematically sound, so you can help students really think and engage mathematically while keeping them going by encouraging them and supporting them and challenging them. It's a difficult job, but one we're pretty confident you can do well. And so we're hoping these materials help you as you engage in those sorts of things. Thanks for listening. We'll be back in week 5 and have some more words of wisdom for you. I hope you're enjoying the course. All the best.